Hello friends and welcome back to my shop. It's like the 15th take of this intro because I just ramble on to oblivion, so we're going to try to rein it in. This week I got the CNC router back up and running, calibrated, found some mechanical issues that I knew were in there and that I had to trace down. So I don't normally use my router for really any kind of work lately I've been doing. I use my lathe and I use my mill. My router really isn't, it's not anywhere as accurate as my mill, but it's much faster. And if I'm doing woodworking or something like that, that's when I want it. I do have some products and ideas down the road where a router is much more suited. That's why it's in this room. So this week I spent time getting that up and running, and then did some drag knife work on it because drag knife is kind of where you see the errors because it's such small little things. So we got that up and running. Did a bunch of mill turning on flex bodies, so we should have a bunch of those up for Christmas. Did some deep drilling work on titanium, which went miserably well, but I figured out what not to do, so that's great. Redesigned some stuff for the Easy Flows, Easy Flow 9000s. That's what's coming in all the flex bodies as of late, so I had to do some minor tweaks for that. Played with this. That's my drag knife that I built like years ago and finally got to use again. That was lots of fun. Let's get into the neat stuff. So the first step was to give myself a bit of a roadmap so I wouldn't get lost. The Z-axis has a 14-tooth pulley and the X and Y have a 10-tooth. Using XL timing belt, that's a I think 0.2 inch. Well, no, I don't think it's 0.2 inches tooth to tooth. So on a 10-tooth pulley with a full rotation, that should move the belt 2 inches. I counted steps here to try to make life easy on myself and came out with 1.8, which is incorrect. It's about 10% wrong. Which as soon as I moved the machine, I realized what I'd done and went back and corrected the math. But that just lets me figure out how low of microstepping I'll have to go. I want it at about 1 thou per inch. Or 1 thou per step microstepping, so anything over 1/16 microstepping was more than I required. I'm actually running it a lot lower than that because the steppers are a little bit overpowered for this machine, and it just quiets the machine down, gets you out of resonance. Microstepping isn't really the way to gain accuracy, but it does help significantly with noise and resonance, so that's why I run it so high. Next up was just putting a dial indicator on it and just double checking that my calculated values work out with the real world values. And I also measure the backlash and add some compensation. X and Y always need a little bit of compensation. The Z is such a small belt that it's usually pretty close to dead on, so just double checking everything. Much easier to correct for it now. Next step was to clean all the rails. So as the machine runs over time, the steel wheels kind of ram any kind of dust that's on the rails into the metal. So I just take some Scotch-Brite every once in a while and scrape them down, and just keeps everything running nice and smooth. Especially plastic. If I cut plastic on this machine, it just kind of forms it into the steel, so nice way to give it a nice good clean. I also checked all the V wheels to make sure they're all contacting the rails nice and tightly. I had one that was a little bit loose, so I just loosened it, tightened the grub screw, and snugged it back up. Every V wheel has its own little set screw, so it makes it really easy. This is a Momus CNC design if you're looking for it. You can buy the plans online, actually. I didn't design this machine, but it's a good little machine. It's quite stout. I'm happy with it. And fully enclosed, so that's nice. I find a good way to check my tolerance after I do all this is with some drag knife work, because you're essentially cutting with like a pin, like a super small knife blade, so that's what we're going to do. I'm going to take a cutting mat, and I'll put some repositionable adhesive on it. Spray it on there, and then we'll use some double-sided tape to hold that cutting mat onto the CNC. I could cut right into that MDF, but MDF's kind of aggressive on blades, and little drag knife blades are not cheap, so I try to keep the edges as nice as I can, and a cutting mat works so much better. Sticking the vinyl onto that repositionable adhesive, and then a couple pieces of tape just to make sure that cutting mat doesn't move. I'm more worried about breaking the blade than I am worried about ruining the cut, so pop my little drag knife into the machine. As long as I don't turn the spindle on, we'll have no problems. I touch off to the vinyl and go about 5 thou into it. I don't need to cut through the back, or I just want to cut through the vinyl, so that's what I set it for. Drop the code in and make it go. So satisfying to watch. So that little knife actually kind of spins around like a caster. Well, it functions almost exactly like a caster.
So in order to do that, in order to get sharp corners, you kind of have to overshoot them. So the program I use is CanBam because it has a plugin for this. I put in my standard vector that I want to cut, and then I run it through a little script that it has on board in it. And that basically puts little whips on all the corners of varying degree depending on how sharp the corner is. And that lets the machine kind of jog past the corner and then reorientates the knife to go in the correct direction. There's a bunch of different ways drag knives work, but this is kind of a passive drag knife, so it only turns by the machine. Some are actively driven that a stepper motor turns it, but so anyways, code looks a little weird, but it comes out square, so that's all that matters. Here I was going to weed the decal on the mat, and then it got annoying, so I just decided to use some painter's tape to use as a kind of a transfer, and then I was just going to stick the sticker onto my mill. Tried to weed it again and pulled it off, and dismal failure. So ran the exact same code again and just was a little more careful with it this time. Peeled it off and then weeded it right on the machine once it was stuck on there. So I don't plan on doing a lot of decal work. I actually use this for masking more than anything, but it's a good way to check tolerance, and it gives me a nice little sticker to stick on my machine, so why not? You can see I made a few changes. So next up, just clean everything up. I put some basically plastic covering on the back of that cutting mat so I can reuse this surface a few more times before I have to reapply and everything. And that's all it is. Nice and easy.
So that is done. I am so glad to get that out of my hair. I mean, the problem is the CNC is like my camera holder and my keyboard holder right now, so it's always on my mind. And I knew there was a gremlin in there somewhere. I just didn't know where the problem was. Like a few months ago, I was doing some pen work on cardboard before I had my laser cutter, and I kept getting a weird shift, a weird error, and I couldn't figure out why, because tolerance-wise, I was bang on, but I would just be out on certain areas, and it turned out to be a loose pulley, but it was so tight still that it only, under quick acceleration changes, it would just shift a bit, and then it would carry at that new shifted location, so impossibly hard to find. And I finally went through and checked every pulley and just Loctited them all in place and found the loose one. So I'm very excited that I got that fixed, because now this machine will function just as it always has, which is perfect. And I like that, and it's off my mind now, which means I can think clearly on other things, and especially when it's under my keyboard, I'm no longer just constantly focusing on it. So, a lot of rambling to say. Thanks for watching, and I'll see you next week. Take care. Bye.